Hello everyone, welcome in channel of Mr. Statistician. Today we will discuss result related to student t distribution. Let's begin. If x follows t distribution with n degree of freedom, then its probability density function is fx of x equal to 1 upon under root of n into 1 upon beta 1 by 2 comma n by 2 into 1 upon 1 plus x square by n raised to n plus 1 by 2 for x belongs to real number. Here x belongs to real number means minus infinity less than x is less than infinity and fx of x equal to 0 otherwise. First result is, suppose x follows normal distribution with mean 0 and variance 1 comma y follows chi-square with n degree of freedom. X and y are independent, then y equal to x upon under root of y by n follows t distribution with n degree of freedom. Here y is equal to normal 0 comma 1 random variable upon under root of chi-square with n degree of freedom random variable upon its degree of freedom n follows t distribution with n degree of freedom. Always remember in this form. Here this result is true when standard normal random variable this and chi-square with n degree of freedom random variable are independent. Then y follows t distribution with n degree of freedom. Second is, as n tends to infinity, t distribution tends to standard normal distribution. This approximation good hold for n greater than 30. That is, here n is degree of freedom is tends to infinity, then its distribution, that is x follows t distribution with n degree of freedom and n tends to infinity, then x follows standard normal. X follows not, x tends to normal 0 comma 1, that is standard normal. So this result is good hold for n is greater than 30. Third result is, moment generating function of this distribution does not exist but moment exists. That is, we know that mu1 dash is equal to expectation of x is first raw moment is equal to 0 for n is greater than 1. Also variance is exist for n is greater than equal to 1. And fourth result is, here degree of freedom n equal to 1, then t distribution is similar to standard Cauchy distribution. Here we given that x follows t with n and n equal to 1, therefore its density function, probability density function of x equal to, here 1 upon under root of n, here n is 1 into 1 upon beta 1 by 2 comma n by 2, here n equal to 1 is 1 by 2 into 1 upon 1 plus x square by n, n is 1 raised to n plus 1 by 2, here n is 1, 1 plus 1 that is 2, 2 by 2 is equal to 1, that is raised to 1, which is equal to 1 upon beta 1 by 2 comma 1 by 2 into 1 upon 1 plus x square, that is equal to, we know that beta 1 by 2 comma 1 by 2 is equal to under root of pi into 1 upon 1 plus x square for x belongs to real number, that is minus infinity less than x is less than infinity. See that this is a probability density function of standard Cauchy distribution, that is Cauchy 0 comma 1. So for n equal to 1, t distribution is similar to standard Cauchy distribution, and we know that in Cauchy distribution mean does not exist. Mean is not, every movement does not exist, that is variance all raw movement central movement is does not exist. Therefore here n equal to 1, t distribution is a standard Cauchy distribution. For n equal to 1, expectation of x is does not exist, because in Cauchy distribution expectation of x does not exist. Fifth result is, if x1 comma x2 xn is random sample from normal mu comma sigma square, then y equal to x bar minus mu divided by s upon under root of n follows t with n minus 1 degree of freedom, where s square equal to 1 upon n minus 1 summation I equal to 1 to n xi minus x bar bracket square. This result is used in testing of hypothesis to test the population mean when sigma is unknown. Here s square is a unbiased estimator of variance, that is sigma square. This result is used in testing H naught mu equal to mu naught versus H1 mu is not equal to mu naught, or other alternative hypothesis. In this testing, we note that test statistic T is equal to x bar minus mu divided by s upon under root of n is used. Here this statistic is this result, and this statistic follows T distribution n with n minus 1 degree of freedom under H naught. Therefore, this result is most important result and which is used in testing of hypothesis.